Assalamualaikum warahmatullahi wabarakatuh. This is our mini project Engineering Science. So the topic is about energy conservation in a skateboard simulator. My name is Muhammad Akmal Hanif Mimbalia and we got 3 members in this group. So the others is Megat Arif Zafran bin Megat Hazwan and another one is Saran Raj anak lelaki Viswanathan. Alright, this video presentation where we explore the fundamental concept of energy, specifically potential energy, kinetic energy, and total energy using a fat simulation of a skateboarder. Kinetic energy. Kinetic energy is the energy of motion depending on the speed of the object. Kinetic energy is calculated using the formula kinetic energy 1/2 mv, where m is mass and v is velocity. Potential energy. Potential energy is the energy stored in an object due to its position in a gravitational field. Potential energy is given by the formula PE mgh, where m is mass, g is gravity, and h is height. Alright. So as the skateboarder is at the highest point, their potential energy is maximized, depending on their height above the ground. When the skateboarder descends, their speed increases, converting potential energy into kinetic energy. Right?
Total energy. Total energy is the sum of potential energy and kinetic energy at any point. Total energy equal to PE plus KE. Without interference from external force like friction, the total energy will remain constant, as demonstration on the skateboard's journey. Top of first hill. At the top of the first hill, the skateboarder's speed is 0, so kinetic energy is 0 and potential energy is at its maximum. Midway downhill, as the skateboarder descends, their height decreases, reducing potential energy, while kinetic energy increases due to the acceleration. Bottom of valley. At the lowest point, the potential energy is at its minimum, while the kinetic energy is at its maximum, thus maintaining the total energy.
Top of second hill. Climbing up to the second hill, similar pattern can be seen where the potential energy increase and kinetic energy decrease, with the total energy remain constant. Okay, next, determine the power of ability, kinetic energy, and amount of energy using the paired simulation energy skate part. Okay guys, we have a result which is mass 65 kg, we have height meter, velocity, potential, kinetic, and total energy. Okay, when 6.0 velocity we have 0, potential 3822, kinetic 0, and total energy we have 3822. Okay, when 4.0 we have velocity 6.0, potential energy 2548, and kinetic 1170, and total energy 3718. Okay, when height 2.0 we velocity 8.9 and potential 1274, and kinetic 2574.33. okay, and total energy 3848.33. when 1.0 height, velocity is 9.8 and potential 637, and kinetic energy 3121.3, and total energy 3758. okay, when height 0, velocity 10.7, potential 0, kinetic energy 3720.93, and total energy we have 3720.93. okay.
And for the discussion, the skater's continuous motion while maintaining a steady total energy validates the principle of mechanical energy conservation. This indicates that the system operates in isolation, with no energy loss to friction or air resistance as assumed in the simulation setup.
I'm explaining the conclusion. The result clearly demonstrate the correlation between potential energy and kinetic energy, with the total energy of the skater remaining constant throughout the movement. And then as the skater moves down the ramp, potential energy transforms into kinetic energy while extending cause the reverse process. The skater's speed increased as potential energy decreased, and vice versa. This experiment successfully highlights the principle of energy conservation within a closed system free from external force like friction. Okay guys, that's all for me. Thank you so much. Bye bye.